Yeah, right. Today we're going to do the volume of prisms. So we've done perimeter. Perimeter is about figuring out um, if you were an ant, how much would you have to walk around to get to the shape, to back to where you started. So that's perimeter. The next thing that we've done is we've done area. So I might have given you a circle and I said to you work up the area of the circle, and that tells you, how much colouring in you need to do, how much space is inside the circle. So that gives you area. Okay, but both of these, so this one here is a two-dimensional shape. Okay, the next thing we're going to do is volume. Volume is where you have three-dimensional shape. So it's not just a flat shape. It's something that has some sort of a depth. So this is like a real life object. Okay, and volume tells you how much space is inside a three-dimensional object. Okay, so you're figuring out how many little cubes you can get inside this three-dimensional object. Okay, so this is what we're doing today. We are doing volume. To give you the units, perimeter is measured in centimeters, area is measured in centimeters squared, and volume, because it's three-dimensional, will be centimeters cubed. Okay. So, let's read. I'm on page 27 of the orange booklet. We're going to be doing some reading, and then when we get to page 28, we'll be copying down some notes. So, volume is the amount of space inside a three-dimensional object. It's measured in cubic units such as millimeters cubed, centimeters cubed, or meters cubed. Finally, volume units can be converted using the chart below. So if you want to go from cubic kilometers to cubic meters, then you don't just times by 1,000, you times by 1,000 cubed. Don't forget that cubed that's there. Okay? So when you do these sorts of conversions, please, it's not just to go from, let's say, kilometers to meters, you're not just timesing by 1,000, you're timesing by 1,000 cubed. Okay? Right. The next thing is to discuss what a prism is. Okay? So a prism is where you have some sort of a shape that looks the same on both ends. So let's look at this triangular prism. Do you see that this triangle over here and this triangle on the opposite end look the same? That makes it a prism. If I was to cut along anywhere here, I would get a triangle. So if I was to cut it along there, that would give me the same triangle all the way through. Okay? The same can be said about this rectangular prism. Look, on this end you've got a rectangle, and on the opposite end you've got the same sort of rectangle. So this calls it a prism. That's what we call prisms. Okay? So all of these shapes are prisms because they look the same on both ends. All of these shapes, although they're three-dimensional, are not prisms. If I look on this end of the cone, that circle is at the bottom of the cone, but at the top there's just a little point. That is not the same throughout. Okay? Look at this spear, right? If I was to cut it along here, I would get a different thing than if I was to cut it along the middle. So all of these things are not prisms. Now the good news is, if you do have a prism, it's really, really easy to figure out the volume of that prism. Because all you're going to do is you're going to say, well, if I know the area of the base, so the area of the base of the prism, so if this is a triangular prism, it's the triangle that I'm looking at, it's whatever area of the base I have times by the length. Okay, so that makes your life really, really easy. Now, what we might want to do is you might want to get your formula sheet out so you can see what formulas you have for volume, and with that, see if there's anything that might help you. Okay? So, do I have a formula sheet? No, I do not. Okay, let me just quickly look it up. I'll show you the formulas that you should have on your formula sheet. Okay, so just bear with me. Okay, so I've got your formula sheet up. Um, it looks like the formulas that you're given are these formulas. So if you get your formula sheet, you should see the following 4 formulas. The first one is for prism, and you've given V equals A times H. The next one you're given is a rectangular prism, and you've got there V equals length times width times height. Then for a cylinder, you're given V equals pi r squared times height. And for a cube, you're given V equals length cubed. Okay, so these are all the formulas that you should have in your formula sheet. I want you to notice something. Notice that in all of these are all prisms. A cylinder is a prism, a cube's a prism, a rectangle is a prism. I want you to notice that all of these will have some sort of a height in them. And then the rest of it is just the area of that shape. So length times width, that's just the area of a rectangle. So that's the same formula as that one. And let's look at a cylinder. A cylinder is something that's got like a circle on both ends and it's connected like that, like a Coke can. Again, if this is your height, that length there, this part over here just tells you the area of the bottom. So this is the same formula as that. And with a cube, right, a cube is the same length in all directions. The length times the length just gives you the area of the base, and then you need to times by another length to give you the height, because that's the height as well. So all of these formulas are exactly the same. It's basically find the area of the bottom of your shape and then times by the height. Okay. We have got 3 examples that we need to run through. Let's see if we can do this. Okay, so first thing is I'm given a cylinder here. So I might want to use the area for the formula for the volume of a cylinder. So I'm just going to copy it down. V equals, this is just from the formula sheet, pi r squared times by height. And now I'm asking myself, do I know the radius? Yeah, of course I do. The radius is just 3. So 3 squared. And then do I know the height? Yeah, the height is going to give me 5 centimeters. And you throw all of that in your calculator. Okay, so pi is 3.1415 times 3 times 3 times 5, and you get 141.37. And now you have to think of your units. Your units are centimeters cubed. Done. That's part A. Let's move on to part B. Part B is a triangular prism. And unfortunately, I'm not given a little rule for a triangular prism. So I have to go and use this formula, the formula for just a prism. Which means I need to find the area of this base. So the base is going to be this triangle here. Okay. And I'm going to think to myself, well, can I work out the area? Yes. The area of a triangle is just half base times perpendicular height. Right, so in this case, the base would be 7 and the height is 8. So this is the height of the triangle, not the height of this prism. They're different heights. So just to work out the area of this base, I would find that that's a half times 7 times 8. And if you do that maths, you will get 0.5 times 7 times 8, you'll get 28 centimeters squared. Now that's just the area of the base, but I need to work out the volume of the shape. Okay? And I need to do it to 2 decimal places. So let's work out the volume. Volume equals, well, for prism, it's just the area times by the height. So I know the area was 28 because I worked that out earlier. And then the height is this number over here, 12. And so you should get that the volume of the shape is 336 centimeters cubed. Okay. So really easy, just work out the area of the base and then times by this height. Okay, this last one is a really easy example. It looks tricky, but they actually told you the area of the base. You already know a lot of the information that you need to know. I already know what this is. So I just need to use the formula for the volume of a prism, because this is a prism. If I cut it along there, it would still give me the same thing on the top and as the bottom. So we've got a prism here. We can work out the volume of it. So the volume of a prism is A times H. Just from the formula sheet, I got that. I know what area is because they've told me already. It's 13, and the height over there is 7. So 13 times 7, you get 336 centimeters cubed. Okay. So those are some worked examples for you. What I need you to do is I need you to give a shot at doing page 29. Okay. When you do page 29, you then need to move on to page 30. Okay. If you finish fast, you have got page 31 to keep you entertained. Okay. I'll give you a hint for question 3. You might want to draw a diagram. So for question 3, you might have to do some algebra. So what volume of water will a rectangular swimming pool with dimensions shown in the following photograph hold if it's completely filled? The pool has no shallow or deep end, it's the same depth. Okay. I seem to have cut out that question. So let's see what the answer is. Okay, so what I need you to do, just draw in this little picture. It's missing there, but we're going to draw our little rectangular prism. Okay. I want to make it 30 meters. Or what units are we using? Let me just see the answer. So 30 meters across, 4 meters up, and can you make it 10 meters deep? Okay, and once you've got that, you should be able to do question 3. I seem to have cut out question 3. Sorry about that. Okay, you should be fine for today. Good luck.